Hello everyone, and welcome back to NASA at Home, where we bring NASA home to you. Today we're going to take a look at what it takes to get off the Earth and into space. Come on. Getting off the planet is harder than it looks. NASA and our partners use different size rockets to get things into space. Whether it's astronauts, satellites, telescopes, rovers, landers, the list goes on, but I don't have all day. Right now, NASA is building the Space Launch System rocket as a part of our Artemis program, which will land the first woman and the next man on the moon in 2024. Let's see how it's going.
NASA's new deep space exploration system has begun its journey right here on Earth, in all 50 states and several European countries. The pieces of the Space Launch System rocket that will send Orion farther than humans have ever been before during Exploration Mission 1 are nearing completion. All these parts will ultimately be brought together at Kennedy Space Center, where Orion is currently being prepared for the mission, to make one enormous rocket powerful enough to take astronauts and cargo to the moon in a single launch, or send robotic probes deep into the solar system to make amazing discoveries.
How does a rocket engine work? Like most engines, rockets burn fuel. Most rocket engines turn the fuel into hot gas. The engine pushes the gas out, creating thrust, moving the rocket forward. A rocket is different from a jet engine. A jet engine needs air to work. A rocket engine doesn't need air, which is a good thing since rocket engines work in space where there is no air. What kind of rocket engines are there? There are two main types of rocket engines. One type uses solid fuel and one uses liquid fuel. The space shuttle used solid fuel in its large white rocket boosters. Fireworks and model rockets also fly using solid fuels. The Russian Soyuz uses liquid fuels. NASA's Space Launch System, because it'll be so powerful, uses 4 liquid-fueled engines and 2 solid rocket boosters so that it can carry very heavy payloads. Why does a rocket work? In space, an engine has nothing to push against, so how do rockets move there? Rockets work by a scientific rule called Newton's third law of motion. More than 300 years ago, English scientist Sir Isaac Newton listed 3 laws of motion. I'll let astronaut Mark Vande Hei explain more.
Welcome to the International Space Station. I'm NASA astronaut Mark Vande Hei. Today, we're going to talk about Newton's third law. How do you think it will hold up in microgravity?
For every action, there is an equal and opposite reaction. This means that in every interaction between 2 objects, there are a pair of opposite forces acting on each object at the same time. A force pair. You can see that there are many examples on Earth. In space, thrusters expel one way and the vehicle is steered in the opposite way.
Hello again. More basketball stunts that I can't do on the ground, at least not while getting this much hang time. All right, back to serious business. I've got a basketball right here. It's going to be object 1. I'm the second object. If object 2, myself, applies a force to object 1, then that same force will be applied according to Newton's third law by object 1 onto object 2. However, there's a big disparity in the mass. Object 1 is a very light mass object. Object 2, myself, is a larger mass object. So I'm going to try to make myself about the same shape as this ball. See how that works for us. And I'm going to apply that force. You saw that force applied to the ball made it accelerate quite a bit. It really didn't accelerate me much at all. Newton's third law again, but this time we're going to use 2 similarly massed objects. Joe and I have about the same mass, so Joe, get into a ball, I'll do the same. I'm going to face you this way so that I don't throw you into something you can't see. Now I'm going to get into a ball behind Joe, and I'm going to apply a force to him. Notice that when I applied a force to Joe, it accelerated Joe away from me, but I got accelerated away from him as well, because the force applied to Joe ended up being the same force that was applied to me. Now you've seen Newton's third law in space. Now test it out on Earth. See you next time.
Thanks, Mark. You can build your own rocket and launch it with some simple materials you can find at home. You'll need a pair of scissors, a pencil, 1 soda straw, 2 pieces of paper, a ruler, and some tape. You'll also want a meter stick or measuring tape. Now, before we begin making the rocket, you want to create a data log on your spare sheet of paper. It should look similar to this, with columns to record the length of the nose cone, your distances traveled for each trial, and any notes to help you improve your design. Step 1. Carefully cut out a rectangle that is 13 by 3.5 centimeters. This will be the body of the rocket. Wrap the rocket body around your pencil, roll it up, and then you're going to want to seal this close completely with tape. Just be sure that you don't tape it to the pencil. It should be able to slide on and off easily. Once you have your rocket body tube, you're going to also want to check that it fits on your straw. You want it to slide on and off easily, but not have too big of a gap. Step 2, making the nose cone. Once you've created your rocket body, you'll want to slide it down to the edge of your pencil point. You're going to twist and pinch the top of the rocket body around your pencil tip to create a nose cone for your rocket. You're going to want to tape the nose cone to prevent air from escaping and to keep it from untwisting. Step 3, cut out and tape on your fins. First, you want to carefully draw and cut out 4 fins. So you can see here I have 4 fins, not 2. 1, 2, 3, 4. Now you'll notice my 2 fins are attached together by a small rectangle. This is so that we can actually tape our fins to the rocket body, but the fins will still stick out like a real rocket. My rectangle right here is about 1 centimeter by 4 centimeters. Now once we cut these out, they should look something like this. Notice that I did not cut the triangles off the rectangle. They're still attached. So I'm gonna line up the end of that tab with the bottom of my rocket body, and I'm gonna put a little piece of tape here and a little piece of tape here to hold on my fins. You can also glue them. Then I'm gonna flip the rocket body over, and on the opposite side, do the same thing with my other pair of fins. And you can fold your fins out so that your rocket can stand just like a real rocket. Step 4, measure the nose cone. Measure the nose cone from its base to its tip and record the length in your data log. Step 5, prepare for launch. Take your straw and place it in the back of your rocket body. Step 6, time to launch. Be sure that your launch area is clear of people and other hazards. Mark your launch point with tape or an object. Then, blow into the straw to launch the rocket. Step 7, measure the distance traveled. Use your meter stick or measuring tape to measure the distance your rocket traveled. Then record the distance in your data log. Step 8, improve your design. Can you make your rocket fly farther? Make new rockets by altering your original design. Try different rocket lengths, fin shapes, fin sizes, or even fin angles. But make only one change at a time, and make sure to record it in your data log so you'll know which design changes result in changes in the performance of your rocket. Step 9, share it. Share your design with family, friends, and your teachers.
You can find this activity online by searching NASA Make a Straw Rocket. También puedes ver en español. Seleccione subtítulos en español bajo el icono de configuración.
We interrupt your scheduled programming for this NASA News Update. Hi, I'm Rod Chappelle for NASA at Home. After 2 years of gathering data and pictures of asteroid Bennu's surface, the OSIRIS-REx spacecraft determined the best place to take a sample and prepare to touch down. On October 20th, 2020, it unfurled its robotic arm and, in the first for NASA, briefly touched the asteroid to collect dust and pebbles from the surface. The sample taken is scheduled for delivery to Earth in 2023. This well-preserved ancient asteroid known as Bennu is currently more than 200 million miles from Earth. The mission launched in 2016 and OSIRIS-REx reached Bennu in 2018. Bennu offers scientists a window into the early solar system as it was first taking shape billions of years ago and flinging ingredients that could have helped seed life on Earth.
Wow, history in the making. The OSIRIS-REx spacecraft is another great example of something launched into space on a rocket. Let's meet one of the engineers who helped with this amazing project.
I'm Nikisha Davis. I'm originally from the Washington, D.C. area. My love for math and science really stemmed from NASA-sponsored programs I attended in middle school. I have college degrees from Spelman College and the University of Alabama in Huntsville in mathematics, aerospace engineering, and systems engineering. I work as an aerospace engineer at NASA Goddard Space Flight Center, where I develop and test hardware and software for point and control systems of spacecrafts. My advice for students is to never give up. Your efforts will definitely pay off in the end.
Thanks, Nikisha. So once a human goes to space, what happens to your body? What do you need to do to protect yourself and stay healthy in microgravity? Let's head back up to the International Space Station to find out.
Hey there, my name is Joe Akaba, and I'm living and working on the International Space Station as part of Expedition 53. One of the best parts about living on the space station is being able to float. Just like you walk from place to place throughout your day, we float from place to place throughout our day. However, we have learned that the same thing that allows us to float, microgravity, is hard on our bodies over time. Our muscles and bones are made of millions of tiny units called cells, and these cells can have problems in microgravity. Up here on the station, bones and muscles no longer have to support the weight of our bodies, so they get weaker. Astronauts could develop something called muscle atrophy, where our muscles become weak from lack of use. Each bone in your body is made of cells too. A healthy bone has more density than an unhealthy bone. Weakened bones can lead to a disease called osteoporosis. Fortunately, our scientists at NASA have figured out one way to keep astronauts healthy and strong. It's called exercise. Let's take a look at how astronauts exercise in space. This machine here is the Advanced Resistive Exercise Device, or we call it ARED. It simulates free weight exercises in normal gravity to work all the major muscle groups. ARED's primary goal is to maintain our muscle strength and mass so that we have less of a recovery period when we land back on Earth. All right, so there's looking at lifting. But what about a little cardio? We have a treadmill for that. Let's check it out. Staying physically active helps both astronauts in space and humans on the ground to stay healthy. And it prevents muscle atrophy and osteoporosis. I'm Joe Akaba, and I hope you enjoyed learning about exercise on the International Space Station. We'll see you next time.
Okay, now it's our turn. Time to exercise like an astronaut. Get up and get ready.
Hi, my name is Heather Paul, and I'm a mechanical engineer at the NASA Johnson Space Center. I work with the Orion program on crew health and medical related topics. Orion is part of the Artemis mission that's going to take us back to the moon, and the crew capsule is big enough to hold up to 4 crew members for up to 21 days. Now, as we learned during the Space Shuttle program and with life on board the International Space Station, exercise during your space mission is critical to maintain your overall health, and especially the health of your bones and muscles. So today I invite you to exercise with me and do one of the resistive exercises that we have selected for the Orion mission, squats. Now, whether you're at home in your living room like I am right now, someplace else in your house, or even in your backyard, squats are a great exercise to do if you're looking to get in a little bit more activity and movement throughout your day. And why not? Train like an astronaut. So let's get started. Come up to a standing position. For a good squat stance, you want to have your feet about shoulder width apart. Draw your belly button in and set your back by rolling your shoulders down and back behind you. Today, I'm just using body weight for my squats, but if you happen to have some weights around or even jugs of water to add a little resistance, you're welcome to go and grab those. So let's get in position, hands in front of your body. We're gonna do 10. Ready, set, go. Down, up, 1, 2, try to sit those hips back, 3, 4, 5, belly buttons in, 6, and breathe, 7, 8, 9, and 10. Great job. All right, shake it out. Do you have it in you to do another set? I know you do. All right, let's get back into position, astronauts. Feet about shoulder width apart. Set your back, draw your belly button in, hands in front of your chest. This time we're gonna do a NASA countdown starting from 10. Ready, set, go. 10, 9, 8, can you get a little lower? 7, 6, 5, 4, almost there. 3, 2, and 1. Yes! Great job. Thanks for working out with me today. Bye-bye.
Woo! You know, exercise is a great way to blow off some steam. Being isolated, up in space, or at home can be stressful or make you feel anxious. Something fun and easy to do that will help calm and relax you is drawing or coloring. They even make adult coloring books these days because it's so effective. So, grab a piece of paper and something to write with, and let's draw ourselves on the moon.
También puedes ver esta actividad en línea en español. Simplemente busca NASA en español.
Did you know that art and design skills are useful here at NASA and in many professions? The studio at NASA's Jet Propulsion Laboratory is a team of designers, artists, makers, strategists, and thinkers. They're passionate about helping scientists and engineers imagine the future and giving people a sense of awe about the universe. Let's meet one of the members of this creative team.
Hey, I'm Lois Kim, and I'm a visual strategist here at JPL.
Here I am part of a small creative design team called The Studio, and I work with scientists and engineers here at JPL, and also sometimes from other NASA centers to help them what we call think through their thinking, and also produce visual products to inform the public of what NASA and JPL are currently doing, and that we call sneaking up on learning.
Most of the research, mission research gets done here at JPL. If they are spacecraft related or robotics related, it's as early as, hey, I have this awesome idea, to we have this much funding, this is our timeline, very refined research stage. This is where our studio is located in. We needed a lot of big open space, and so we had to take down a few walls inside to kind of create a collaborative space. But I'll show you guys inside. So this is where I work. This is where the studio is at. I have a motion graphics background, and so that taught me all the modeling skills, rendering, texturing, and animation, but also took a lot of storyboarding classes. I love the idea of being able to jump from building, installations to doing something interactive, to doing something print-based. Being able to know how to show my projects and verbally communicating that with other people was a huge skill that I learned from Art Center. It makes me think of what's out there and all the possibilities that are out there, and somehow implementing creative design into that and bringing that to life on Earth. It's amazing to kind of see what I get to do every day, who I get to interact with every day, engineers and scientists that some of them discovered those planets, and I get to sit down with them, brainstorm, talk to them, ask them questions. What is that planet? What does that spacecraft do? What's the mission? What does that part do on the spacecraft? Like, we all have one thing in common, which is we're all curious. We all want to know what's there, what's out there, and how we can contribute our talent to figure that out. And it's just amazing I get to do that every day.
Wow, what a cool job! When people think of working at NASA, most people think of astronauts. But thousands of people work for NASA all over the country, and most of them are not astronauts. Let's take a look.
Before I started working here at NASA, I had my own sewing business.
I was helping in a folkloric festival in Argentina, so I was running the horses.
I was also a bartender at a music festival.
My name is Paula Kane. I am a thermal blanket technician.
I'm Geronimo Villanueva. I'm a planetary scientist.
My name is Joy Eung, and I'm a video producer at NASA.
I am from Capitol Heights, Maryland.
I was born in Mendoza, Argentina.
I'm from Devon, which is on the southwest coast of the UK.
So I was a fashion design major. Ended up designing clothes for satellites, basically.
Electrical engineering actually was my undergrad. And then my master's was in telecommunications. Then I went to Germany, this is when I did my PhD, and then it became astrophysics.
I did my undergrad in biology, which I loved, but I also loved many other areas in science too. So I decided to do a science communication course for my master's.
Well, I ended up working here at NASA. It sort of happened by mistake. I used to always check the Washington Post ads for jobs, and they had one that said, are you a Star Trek fan? Do you think about space? And it said, come work here at NASA as a thermal blanket technician. Had no idea what it was, so I called, came in for the interview, and I got the job.
So when I moved to Germany and started doing my PhD, I discovered the European Space Agency, the German Space Agency, and started working in connection with NASA. So when I finished my PhD, this is when they offered me a fellowship to come here to NASA Goddard Space Flight Center. It was supposed to be for 2 years, and I've been here for 15.
When I first started working at NASA, I started out as the Earth Science Multimedia Fellow. So I was on the Earth Science News team covering breaking news.
When I thought of NASA, I thought of space, I thought of futuristic things, I thought of the Jetsons.
Even if you hear NASA, you think about these genius people.
As a kid, I never thought I could work for NASA.
When I got offered to do the fellowship here, I actually was scared to come here because I'm gonna say, oh my God, am I actually qualified to be working at NASA?
Okay, what it means to me now being a NASA employee is that the sky is the limit.
Then once you arrive here and you realize that it's just people that have passion for space. That's the main thing that defines a NASA scientist.
To work at NASA, I think you have to be really curious about the world.
You just have to find your niche and where you can fit in here, because you can fit in here.
If you have that passion for space, don't let anybody tell you what are your limits.
There is definitely a job for you. There are so many jobs here.
The fact that I am here doing it and I'm getting to touch things that are going into space, working here now, I'm doing things that people would never even dream of. And I'm a fashion designer, so don't let your preconceptions of what people think stop you.
Great work today. Thanks for joining me for NASA at Home, and don't forget to check out more activities to do at NASA STEM at Home for students. See you next time.